Hi, good morning, everyone. My name is Neil Costigan, and I'm the CEO at BehavioSec. We're a European IT security company where we develop, well, what we hope to develop, or our mission to develop, is transparent IT solutions. The idea is that we don't believe the user should be part of the security solution, that this complex smart cards and PIN numbers and SMSs and these kind of things limit usability of a system. And so what we've developed is a behavioral biometric that allows our customers, primarily internet bank and mobile solutions, to get security without adding a burden on the end user. And when I say behavioral biometric, what we do is actually we monitor and analyze how the user interacts with their device, be it the web browser for their internet bank, be it their mobile phone or tablet for mobile banking, or indeed their desktop in an IT environment. And when I say interact, what we do is we capture how the user interacts. It's the rhythm of how they type, their keystrokes, not necessarily what they're typing. We're not looking at the passwords or their usernames, but it's how they type them, the rhythm, the speed, the frequencies they go across the keys. People tend to type things they know, like passwords and their usernames, in a very reflex way. Similarly then on mobile, we can capture things like the gesture, the speed they move their finger across the screen, the pressure they put on points, the acceleration, the velocity, and that kind of thing. And the idea is then that our technology is transparently put into the website, into apps, and in the back end, the customers, the security people or the anti-fraud people, in real time can determine a score to verify that the user is who they say they are. For my first demo, I'm just going to go and show off what one of our customers are using in a typical e-commerce shopping cart. So underneath the hood, in this standard form, which they're filling in credit card information and expiry, I've pre-filled in a bit to make the demo a little bit short. But as I type, the address and the shipping details, underneath the hood, our technology is passing the rhythm of how, hold on, I get this right. The software is just capturing the events, when I hit the keys and when I release the keys. And in the back end, our patented machine learning algorithms, which are an AI engine very similar to how a computer game learns the behavior of a user. We're monitoring how the user is interacting and comparing it to what they've done in the past. Now, normally what would happen here, this is a successful login, my typing rhythm is who I say I was, and the score would come back in real time and say, yes, this is the right person, or not. And if it's not that person, the customers tend then to go and ask the security question. So rather than putting the security up front and expecting the user to know, to have a PIN card or a calculator or a smart card, what they can do is only ask that question if the behavior is failing. And if you see it in what we call our dashboard, I can look at that transaction I've just done. And the last one here is me. I can dig down and analyze it. I can look at the various parts. And in the part here, the checkout that I've just done, we can go and break it down into the individual fields. The scores are in there. It's how likely that it is me. A high score shows that it has been me that's been typing, and that my behavior has been very consistent. But if I take a previous transaction, something I've done just earlier on when a colleague of mine came along and hijacked my session, what you can see here in the graph is that I logged in successfully, but somebody else then tried to type out the various fields, to type in my credit card number, to type in my shipping address and that kind of stuff. And joining all these together, we can come up with this score and show it off. Now, this is just a view that the fraud officer, the security people would see. This isn't anything the end user sees. All the end user gets is a straight experience if they're the right person, a nice shopping experience. And if they're the bad person, they're challenged to go and produce more credentials. Very much like if you had your credit card and you're shopping. If you're shopping every week in the local store, everything's fine. But the day you go off and use that credit card in a holiday resort and buying expensive stuff, the credit card company sees the behavior is different and goes and challenges you, falsely blocking the transaction or just sending you a phone or phoning you up and asking you, is it you? And this is how our customers are using this. As I said, we're a European company. We will have this in the new year, we're in the tens of millions of users with their internet banks enabled with this technology. So all the Scandinavian banks have adopted the technology and put it in as an additional new layer of security, allowing them to use very simple usernames and PINs and passwords as the security mechanisms. But with this transparent layer, they're able to increase the security and save costs of managing hardware tokens and hardware devices. And if you can switch now to the mobile. The mobile is a very interesting platform that we're taking standard phones, standard hardware. This is a standard Android device with nothing special on it. No extra fingerprint readers or sensors or cameras or anything. And when I put in my normal pattern to unlock it, everything is fine. It's a standard pattern, standard thing people are used to in their phones. But actually what we're doing under the hood is we're watching the pressure the user puts on it, the angles, the speed, the acceleration, the velocity. And so if I go and do an exaggerated, slow, fast, and a funny angle on the same pattern, it doesn't get in. So there's these extra layers of security are put there, and they're completely transparent to the end user. So not only do you need to know the pin or the pattern, but you got to know how to put it in. Now it allows for variances. We're not looking for somebody to be a robot. The algorithms are quite smart that they allow small variances, but we're able to detect, and we've proven this in large user trials where we have millions of users out there, that we're capturing 99.7% of users who know credentials of another user and they're trying to break into the system. All these details we have on our website. There's white papers and examples and customer case studies, but we'd also like to show it off at our booth. If you come by, we can demonstrate the mobile, our dashboard, the real-time scoring, and other scenarios such as login. In this case, we had checkout, but also other enterprise-type scenarios where people are interacting with websites, and it's important to know that the user is who they say they are. And finally, just to show it working in mobile, now that I've got a little bit of time, this would be the standard authentication app of most of the Scandinavian banks. They have their own custom keypad, and it's just a 6-digit PIN. And when I type in my 6-digit PIN here, in addition to the PIN being checked, it's going across the wire. And I've got the demo daemon there where, of course, it doesn't show off. When I don't type my behavior normally, I'm typing in my own PIN. And in the back end, it's doing an analysis. There's a 98% that it knows the rhythm, how fast I move from key to key to key. And if I look at that in the same dashboard, in the back end, in real time, that score has been registered in there. And you can see a list of, there we go, there's my time. But if you look, there's an example of the mobile app being used in real time. So thank you for your time today. We're BehavioSec, and I'd love to show off our stuff later.